we want to welcome you to another exciting statistical topic. Of course, this particular topic can also be found in machine learning. It's one of the machine learning algorithm. Today's topic is regression trees versus random forest. Of course, the other time we started non-linear regression. So I'm going to, I can confirm to you that this particular topic, okay, fall under the non-linear regression. Okay, so it's a variant of non-linear regression, a technique in machine learning world. Now, regression trees and random forests. Of course, we use them in classification problem. We also use them in, prediction problem. So today the focus is going to be on these two variants of nonlinear models. There've been kind of arguments around, looking at regression trees and random forest regression. But I'm basically going to differentiate between the two using an example right now. I need to focus on this. I want to use an example. Like I said, we use decision trees, and decision trees are also called regression trees. So we use regression trees and random forests in classification problem. Let's say, let us pretend as if we're in our bank now. Okay, there is a bank now, and customers approach us for a loan. Of course, the outcome is going to be, there are going to be two possible outcomes, right? It's either the customer was considered loan or not. But I want to believe before the customer can be considered a loan, the bank will consider some explanatory variables like credit history, income, loan amount, and so on. But if you take a look at what I'm displaying now, okay, I want to use this example to distinguish between regression trees and random forests. I'm going to say that again. I want to use this very example to make a distinction between regression trees and random forests. Now, if the bank want to take a decision very quickly, I'm going to say that again. If the bank want to take a decision very quickly, the bank will use decision trees, which I call regression trees. I'm going to say that again. If the bank want to take a decision very quickly, they're basically going to use regression trees. But if they want to develop different kind of strategies, and they want to have like, different decision processes, and they want to take their time, study all the possible, decision process, and they combine in the end, and they take their decision, that means they are using random forest. That's what I'm going to say that again. When the bank want to decide whether to give the loan very quickly, they're going to make use of decision tree. But if they basically want to generate, okay, they want to use another strategy where they generate different scenarios of the process. They're actually going to combine all of that. They take their time. Of course, they're basically using random forest. The example I'm showing on the board is an example of decision tree. Now, the credit history here, the bank prioritize among the explanatory variables. This bank actually realized the most important predator is the credit history. That's why they are starting with the credit history. As you can see here, the credit history is categorical. It's either you have a good credit history or you have a bad credit history. Take a look at that. Now, when I go to the income, it's either your income is low or your income is high. This is like a financial condition. Okay, whether income is low or high. Now, the amount you are seeking to get from bank, the amount you are seeking approval for could be a small amount, could be a large amount. Now, based on what I'm displaying now, using decision tree, because this particular bank want to take a decision on time, okay, they prioritize credit history. I'm going to go all this way now. When the credit history is good, you see, when it is good, then they're going to consider income. When the income is low and the amount the the customer is seeking is small, that very green button, green mark actually means that person is considered. I'm going to say that again. If you want to go through the other way, in the left side, credit history good, income low, the customer is requesting small amounts, then that customer will be offered. That customer will be given the loan. Now let's go another way. A very good credit history, right? Income low, but the big amounts. What is the meaning of that? X. The bank did not give out the loan. Does that make sense? Because the amount is seeking is high, but I want to believe what pulled him down is a low income, even though the credit history was good. Now let's proceed the other way. A credit history good, income high, oh my God, whatever the amount. Look at that. Whatever the amount, whether small or big, this bank is going to consider. Does that make sense? Because there are two variables that favor him: good credit history and high income. Maybe, of course, this guy saved with the bank, save his salary with the bank. Now, let's now go to bad. Let's go to bad credit history now. Like I said, using decision tree, the bank want to take decision very quickly. And this is what the bank is using. This is algorithm, the decision algorithm the bank is using. Now, if somebody have a bad credit history, low income, whatever the amount, because they are double tragedy now. Okay, bad credit history, low income, whatever the amount, whether big or small, the customer is trying to get, this particular bank will not consider that. Now, let's go to another one, bad credit history, but high income. Then this customer is looking for small amounts, then it's likely going to be given. But look at the last consideration, bad credit history, high income, and big amounts, then the customer is not considered. Now, does anybody here understand how decision tree works now? Okay, this is just based on a single decision tree. Okay, now, and the bank here actually they believe that the credit history is the most important. The credit history is the most important, and that is why they are starting from there. But let me tell you this. Do you know that a bank can make a wrong decision using the decision tree? Because of the fact that, how do I know? They're basically going to make wrong decision. if we try another decision tree where we don't put credit history first, maybe we put income first, okay? Now, the result that we got is different, and we have a way to compare our decision tree, okay? And that is the reason why we actually want to consider the random forest, where we're going to have, combinations of this possibility, okay, which is going to be this guy. Take a look at this picture now. I'm going into random forest. The random forest, the advantage of this is that this will lead to accurate prediction compared to decision tree. Even though this has a complicated visualization compared to decision tree, okay? Now, when you take a look at what I have now, in the random forest, they randomly select, decision trees. Now, each of this now starts, starting like a decision tree. For what I'm showing you now, it's like I have n number of decision trees, which means the bank, they've changed their strategy this time around. So what they're going to do in one decision tree, they're going to consider credit history as most important variable. And maybe in another decision tree is maybe income. Maybe in another decision tree is basically going to be the amount the customer is trying to get. Now, in the end, we're actually going to have results that will come from each decision tree, okay? And there's going to be voting, okay? Majority voting that we're actually going to call the averaging will lead us to final result. Does that make sense about how the algorithm of the random forest and decision tree work? Now there's something I'm going to show you here. Do you know this guy here? Okay, the guy that have a bad income, okay, where they have a bad income and low, or let me come to the last one. The last one has a bad credit history, but the income is high. And the bank believe that because it's seeking for big amount, they're not going to consider the guy. If the bank has made a wrong decision doing that, they've lost money. Because the bank is not giving out loan for free. Are they giving out loan for free? No. The loan is going to come with interest. So at times bank made wrong decision. Of course, there are some people that they've trusted and they default. It has happened before. And so it is not all the time that somebody with a bad credit history it's likely going to, it's going to default. And that is the reason why decision tree may not be a very good algorithm to consider in classification, but we only use that when we want to take a quick decision. But if we want to take our time, what we're going to do is better to generate, to randomly generate a set of decision trees. And in the end, we're actually going to combine that and get a very good result. I believe, is there anybody now, whether online and in person, that doesn't really understand how the algorithm of decision tree and random forest work? Is there anyone? We need clarification. I just use the example now in bank. You're giving out bank loan. You can use the same example. I said this is using a classification problem. Or for instance, somebody applied for graduate, graduate admission. Okay, PhD or master's admission. I know at times some school could make wrong decision in admitting or not admitting, where in that situation, they're going to base it on the prestige of the undergraduate school. Okay, prestige of the undergraduate school, the makers of the GRE score, GPA. But are we now trying to say students from a low prestige undergraduate school, does that mean they are not intelligent? Because that's one of the factors they use. So at times, if they make a wrong decision when we make wrong decision when we are classifying, if we now want to reduce, okay, the probability of misclassification, okay, I strongly believe random forest is better than decision tree. Okay, now I'm gonna, like I said the random forest has complex visualization, as you can see in the algorithm I display. Okay, but it has an accurate predictions compared to decision tree with a simple visualization. Okay, but less accurate predictions. Okay, so, and another advantage we can have with the random forest, it can prevent overfitting. Overfitting, you remember the other time when you are trying to solve the problem of bias and you are incorporating more independent variable into your model, even though you may address the issue of bias, but you are creating another problem, which is going to be high variance. And the high variance will lead to overfitting. What do I mean by overfitting? Your model will perform very well with a training set of data, but it's going to perform poorly with a test. Don't forget, you're going to split your data set into training and into testing. It's going to perform so good on training, but it's not going to perform so good on testing data. And you know why? Because your model has captured noise. Your model is supposed to capture only signal, but that very model capture noise, it's not going to be a good model. So therefore, the random forest can actually avoid that. The random forest can avoid that because of the fact that majority, is going to put into consideration all possible decision trees to come into conclusion. Okay, how to choose between decision tree and random forest? Okay, and I said here, random forest is suitable when we have a large data set. Large data set. And interpretability is not a major concern. Because if interpretability is a major concern, that will be a problem. Okay. Now, but when you take a look at decision tree, looking at the algorithm that I showed you the other time, they are much easier to interpret and understand because you only have just one decision tree. Okay. So the takeaway is just that the random forest combine multiple decision trees, as you can see. Okay. Okay. Now, I want to go into another example now. I know some of you like sports. We just use an example in a bank now. Okay. But let me first tell you, I told you the other time, whether regression trees or random forest, they belong to the class of nonlinear regression. And of course, they've been proven, they perform better than using linear regression. Does that make sense? Now, I want to go into a sport now. I want to use another example in sports. This time around, I want to talk about baseball. Oh my God, I miss baseball. Okay, now for example, suppose we have data set that contain the predictor variable, years played, an average home runs, along the response variable yearly salary for 100 of professional baseball players. Now, when you take a look at this, we're looking at the effect of years played and the average run on the salary. But when we are using regression trees, you know what happened now? You know what this regression tree prioritize as the most important variable, okay, to predict salary is the years. Can you see that? And after years, you consider home run. Now, what is the first one saying? The years of the years, as you can see here, okay, the years played, okay, can be categorized into less than 4.5. Okay, the left side is less than 4.5. The right side here is greater than 4.5. Does that make sense? Now, take a look at 225.8. The 225.8 that you are seeing now is the salary of those players who have played less than 4.5 years. But when you come to the right side, okay, for greater than 4.5, okay, we have another that's actually lead to another variable that was categorized. We call that home runs. The left side here consider those who have home run less than 16.5, and the right side those who have home run more than 16.5. Now, if I want to go from the top, okay, to the bottom now, look at what I'm going to do. If I go from more than 4.5 to home run less than 16.5, the salary is 577.6. Does that make sense to everyone? If I go back again to years played more than 4.5 with the home run greater than 60.5, the salary will be 975.6. What do you see here? The players with more years played and more home runs is likely going to get more salary. Does that make sense? That is what this decision tree is actually suggesting. Is there any question on how I interpret the decision tree? I think I also need those who are online to confirm if they're still hearing me clearly. Those of you online, can you confirm if you're still hearing me clearly? Okay.
Yes.
Thank you so much. Thank you for confirming that. And this is the interpretation I provided here based on that algorithm. Okay. So I said the player with the less than 4.5 years played, we have a salary of 225,000, 0.8. Okay. And the player with a greater, so this is more or less like what I explained the other time. And of course, it means player with more years of experience and more average runs, home runs, will basically have more salary, as you can see. Now, do you know, based on this decision tree now, this decision tree actually prioritize years played as the most important predictor variable. Take a look at that. Now, you can actually use this to make a prediction. Let's say you have a particular baseball player now. Okay, this guy has 8 he has 8 years played. Of course, the 8 years play is going to be to the right of the other side, right? Okay, to the right here. And this guy has 10 home runs. The 10 home run is less than 16.5, right? It's going to be by the left side. What will be the salary? The salary will be 577.6K. Does that make sense? Now, I'm using that decision tree now to make a prediction. Okay. Now, I want to go into the step that we actually apply. Okay, step 1, if I want to put on decision tree. Okay, we're going to use a recursive binary splitting to grow a large tree on a training data. Don't forget, you're going to split your data into 2 sets, right? And we basically want to grow a tree on that. We are growing a tree on the training data. And the other time I've been talking about predictor, right? In the case of the bank, I talk about credit history. I talk about the amount, and I also talk about the income. Those are 3 predictor, right? And in the case of the baseball example, I talk about the years played, and I talk about the home runs. Those are just 2 or 3 variables. But what if in a situation I'm generalizing now from X1 to XP? If we got P numbers of predictor variable, okay, we needed to have a cut point, okay, and the cut point such that the resulting the residual sum of square will be the lowest. Now, step 2, then we're going to apply the cost complexity, where we want to prune to the large tree. We want to prune to the large tree. We don't want that tree to have a lot of branches like that. We want to be able to control that, okay? And, pruning to the large tree to obtain a sequence of best trees as a function of what you see here. So if I want to minimize the residual sum of squared, there's always going to be a penalty. That's why you're going to have RSS plus alpha t. Okay, so and I said when you increase the values of alpha, then the trees with more terminal node are penalized. We don't want a lot of node. Does that make sense now? When you have a lot of node, that is more or less looking like working with a linear regression where we got a lot of predator and we're trying to shrink. You remember lasso? We did the same thing in lasso regression, right? Where we introduce a penalty, lambda, which we call a turning parameter. Okay, so and I said this ensures that the tree doesn't become too complex. We don't want the tree to become too complex because if the tree, some people may be thinking that, oh, when I got a lot of node, I'm actually going to get very the best result, but that may come at the expense of efficiency, and that is the reason why we needed an alpha here, okay, that will serve as what I'm going to call a regularization, that is going to do a regularization job. Okay, then we're going to use a k-fold cross validation to choose alpha. Okay, I'm going to walk you all of that. Okay, we're actually going to choose alpha that will minimize the test error. Where am I going to get a test error? From the test data. I will build my model on the training data. I'm actually going to test that on the test data. Then finally, the moment I actually choose my alpha, okay, my alpha that actually correspond to, to the minimal test error, then I'm going to choose my final model. I think I just gave you here the pros and the cons, okay, of decision trees and random forest, easily interpret, you can explain, you can visualize, okay, and of course they apply to both regression and classification problem. And of course I said something here, they tend not to have as much as predictive accuracy as other non-linear machine learning algorithm, because we also have other non-linear machine learning algorithm. I don't know whether you guys have heard about KNN neighbor. There's another one we call I think there are a lot, there's a lot of them that we have around, okay, that we can actually talk about. Okay, now I think I've explained all this, the reason why we use a random forest. Okay, I said however, the downside of using a single decision tree is that it tends to suffer from high variance. Okay, and high variance will lead to overfitting, right? Okay, now we know when we split our data set, we're actually going to get different results fitting decision tree. Okay, and a method that we can actually use to reduce variance. When you reduce variance, then you are preventing overfitting. Okay, and if I want to reduce the variance associated with a single decision tree, then what I'm just going to do is to build a random forest model. Okay, so this is the procedure, but I will quickly, because of my time, I'm going to walk you through how to do that in R. It's super easy. Okay, I'm using a data set that contains information about employees who work in a company. This data set can be found online. Okay, and you know what I want to do? How do I know decision tree may be having issue? I can create two separate decision tree and see whether they take the same decision. They are not likely, because in each of the decision tree, the variable that we prioritize is different. I mean, what we call the important predictor variable is actually different. Now, if you want to have access to the data, you want to run the regression trees, you also want to run the random forest, you need to install all these packages, ggplot2, the light, the dplyr, and so on like that. And you're also going to need to load random forest. Okay, because you know what I want to do in this example? I basically want to compare decision trees with the random forest. But before I compare decision trees with random forest, I for us want to compare different kind of decision trees. This is the first 6 in the data that I'm actually using. And you know what I want to predict? This guy, salary. The salary here is categorical. Therefore, this becomes a classification problem. The salary could be low or, low, medium. I'm actually, if you take a look at what we have here, and we got a lot of predictor here, the satisfaction level, the last evaluation, the number of projects, average monthly hours, time spent, okay, then the company work accident, whether left or not, the promotion last 5 years, then whether it's in the sales department or not. We're talking about employees here. Okay, do you understand the data structure now? We're looking at the effect of so many variables on salary. The salary here is categorical. And that's why it's a classification problem. Okay, now these are the columns. Like I said, we got 10 variables. Okay, 9 predictor variables and 1 response. The response is salary. It's categorical. Okay, now the very first thing we do, okay, is to exploit our data. We do data exploratory analysis because there's a possibility there could be some data may be missing. Look at the code here. Some parenthesis is dot add a into data is trying to tell me there's no any missing data. Okay, because we need to clean up. This what we're doing now. It's what we call data preparation. We don't just analyze. We need to analyze when we have already ensured that we've done some cleaning. Does that make sense now, right? And of course, returning 0 here means we don't have missing values. Then let us now, when you take a look at the salary, like I said, the salary is categorical. It has 3 levels: low, high, and medium. And part of the descriptive analysis that we did, okay, 1,237 workers, they earn high salary. Does that make sense? And 7,316 workers, low salary, and 6,446 workers, medium. Does that make sense? This is just giving us the sense. This is a descriptive analysis. We just want to have a sense of the number of workers in a particular category, with regard to salary. Okay, we're still on the exploratory data analysis. We want to group this by constructing what I call a bar chart. I'll take a look at this guy now. Okay, if you take a look at what I have now, when I talk about the count and trying to, what I have in the predictor is actually left, then you're going to see the color here represents the number. When you take a look at left, the left is categorical, is one of the predictor. It said it's 0 or 1, okay? Labeled as 0 or 1. So when you take a look at the 0 part, the one we label 0, okay, that will enable you to compare how many how many workers belong to a certain category within the salary structure. The salary, so as you can see, Oh my God. Those that are earning high salary here, they are very, very few. Can you see what that chart is? It's telling, it's giving us a story. Okay? Very, very few. And those who are earning low and medium, they are they are very close. Okay? When you put into consideration the different class. Now, in machine learning algorithm, we normally split our data set. This is a little bit different from what we do in statistical analysis. In statistical analysis, we make use of the entire data set, but when you make use of the entire data set, then your intention is to explain. But if your intention is to make a prediction and you're working with a high dimensional data set, I think it's better you split so that you'll be able to test the performance of your model with the testing data. Now we can split 80-20, 70-30, so on like that, but we just have to ensure the largest percentage of the data is committed to training. Okay, so what I'm trying to show you now, okay, I'm actually splitting now. Okay, so splitting now, I'm going to have a train set, I'm going to have a test set. Okay, now I want to feed decision tree now. How do I fit? The decision tree that I'm actually going to fit, I'm going to fit that on the train data. I'm going to fit my model on the train data. That's exactly what I'm doing here. Look at that. The arrow part, the satisfaction level, what I'm interested in now, if what I'm fitting now, I'm no longer talking about salary anymore. Okay. I'm actually interested in satisfaction level, not the salary now. If you take a look at the response here, satisfaction level. Does that make sense? The satisfaction level can actually be used in place of a salary. I'm going to tell you maybe why we may want to go by way of salary, because this is unbalanced. Can you see unbalance? The numbers of employees getting more salary is very, very few, but that doesn't mean they're going to be happy. And that is why an important response variable should be the satisfaction level. You can be getting a high salary and you're not satisfied. And somebody who is getting a low salary may be satisfied. And that's why we're choosing a new response variable now to be satisfaction level, where the predictor at the last evaluation, the number of projects, the average monthly hours, then the time spent work, in the company. And of course, we're using the train data. Don't forget, the train data is the 80% of the data, not the whole data. Oh my God, take a look at the decision tree now. Do you see that? This particular decision tree prioritizes the number of projects that particular employee actually embark on in that company to be the most significant predictor. Look at that. Okay. Now, how do we make a prediction with that? This is a code now. And if I want to make a prediction, what am I going to be targeting? The test data. That's why you see X_test. Does that make sense? So my prediction now, I'm actually going to compare what I predicted with what happened in reality. Does that make sense? And because of that, we have to evaluate, okay, the module of evaluation that we have and run. We have MAE, we have the mean square error, root mean square error, and the R squared. Take a look at that. Now, when we compute that for that particular decision tree, these are the values that we have for the MAE. So the MAE, the RMSE, the RSQ, they are the evaluation. I'm going to call them metric of evaluation. Now, if I actually go for another decision tree, I'm going to call this decision tree 2. Okay, if I should go for another, when you take a look at what I have, what I initially have, okay, I actually use last evaluation, the number of projects and the like, but in another decision tree, I am making use of the work accidents, promotion last 5 years, whether it's stay in the company or not, the salary, the sales. Take a look at this now. I'm building another decision tree on that. Okay. Now, building another decision tree on that, I calculate the evaluation, the metrics of evaluation again. We can compare the metric of evaluation in the decision tree 2 and the decision tree 1. If you look at that, there's a different, when you go back here, the one that have a minimum MAE, the minimum RMSC is going to be the better one. Okay. So when you compare 0.149 with the 0.182, and that was why the first model is performing better, okay, than the second model, because it has a low, let me tell you the most important metric of evaluation that we normally want to prefer is the root mean square error. Okay, the root mean square error of this one is 0.195. Okay, compare 0.195 with 0.228. The first decision tree will be preferred. Does that make sense now? Now, on the same data, now look at a conflict now between them, okay, due to the fact that they, what they prioritize in terms of the predator. Now, if I now decide to go with a random forest now, the random forest is trying to say, I'm going to use a lot of trees, not just one decision tree. As you can see here, I put that satisfaction on last evaluation on that data again. Okay. And the numbers of trees, I put 1,200. And I'm also going to train that, okay, importance true. Okay. Now I'm also going to, after learning the model from the training data set, I'm actually going to evaluate the model based on the test data set, and I'm actually going to compute the evaluation, what I call the metric of evaluation again. Now, when you take a look at the root mean square here, it's 0.18 compared to the one that we say is better. It's 0.195, it's 0.8, it's 0.18. Of course, the random forest here is actually preferred. Now, because the random forest here is actually preferred because of the fact it has the lowest RMSE. The RMSE is what we call the root mean square error. Root mean square error. Now, do you know with the random forest model that I fed, how am I actually going to know the most important predator? I'm just going to write importance into that. Don't forget, when I was fitting the random forest, I actually use ROF underscore model. So if I want to know the importance one, okay, this is the importance one. You take a look at that now. The one that has the maximum value, 163. 163 is the largest here, which means the number of projects, followed by what? Average monthly hours, followed by last evaluation, and followed by the time spent in the company. Take a look at that. So this is how to get the variable importance using the random forest. What is the summary? Of course, the root mean square error from the random forest was even better than the root mean square error, the lowest root mean square error that we choose for the two decision among the two decision trees. And that was why I said, therefore, the random forest is performing better than decision tree. And I said, in addition to look at the importance features, we see that the average monthly hours and the number of projects are the most important variable to evaluate the satisfaction level. Any question on what we've done today? Regression trees and the random forest. Any question? Any question about the decision trees and the random forest? I'm actually going to have a takeaway from today's lecture. The takeaway from today's lecture is I introduce you to regression trees that we also call, decision trees. we compare that with the random forest. The two of them are variants of nonlinear regression model. And of course, we use the two of them in both classification problem and prediction problem. And of course, today we have used them in classification problem. I gave an example from, a bank example where customers approach a bank for bank loan. And of course, I said the difference between decision tree and the random forest, if the bank want to take a decision on time, they will use decision tree. When they use decision tree, they're actually going to prioritize a particular explanatory variable. I think the one they prioritized was credit history. And after the credit history, they look at the income. And after the income, they look at the size of the loan that customer is seeking. And I said, and with that decision tree, they could make a mistake where they could lose money. Okay. And if they now want to consider a robust way of doing that, they basically, generate randomly good numbers of decision trees where they're going to combine them, and using the majority vote, they're going to arrive at the final model. So we apply that, to a question, a problem that has to do with employee satisfaction. And of course, we splitted our data set into trading and testing, whether we want to use, want to fit regression tree algorithm, or we want to fit random forest algorithm. We're actually going to build our model with the training data set. The training data set, the majority of the data set will be committed to training, or probably you could use 80 to 20 or 70 to 30. And when you learn your model from the training data set, then you're going to evaluate your model with the test data. And we use some metric of evaluation. And of course, the most popular among the metric of evaluation is the root mean square error. And of course, when I use two different decision trees, you can see there is, we got different results. And we compare the best in the number of decision trees that we compare, that we actually, that I walk you through here with that of the random forest, and using the metric of evaluation. Okay, we have called the root mean square error. We find out the root mean square error of, for the random forest was actually less than that of the decision tree. And finally, we also look at, the variable importance. Okay, we got a coding now to get a variable importance using the random forest. Any question? Okay, in the absence of question, this is where I'm actually going to stop today. Make sure you stay safe and have a lovely day. Bye for now, everyone. Okay, thank you too.
Thank you.
You're welcome.